So I'm going to explain this point number 4. Calculate standard cell potential by combining two standard electrode potentials. Use standard cell potential to, then the next one, to find the polarity of each electrode, hence explain the direction of flow of electron, etc., 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 etc. Okay. First of all, I would like to show you a general full cell. The combination of two half cell is going to make full cell. So here is the general diagram of a full cell. For example, here is a beaker container that is having zinc rod in it, and this zinc rod is dipped into a solution that is having zinc 2 positive ion aqueous solution, and its concentration is 1 mole over dm cube. So generally speaking, this is a half cell, a zinc half cell, Zn2. Its notation is Zn2 positive slash Zn half cell. There is another half cell. I'm going to connect it, this half cell with another half cell that is having copper rod, Cu rod over here, copper, and here are copper 2 positive ion, copper 2 positive ion aqueous, that is also equal to 1 mole per dm cube concentration. If I'm going to connect these two rods by a wire, external wire, via voltmeter, this is the metallic copper rod dipped in aqueous copper 2 positive ion. This is the metallic zinc rod that is dipped in solution of zinc 2 positive ion. And I'm connecting these two rods via wire, via voltmeter. Here we also we are supposed to place a salt bridge. I will let you know what is the function of the salt bridge. So number 1, as far as the data booklet is concerned, what is the answer of this half cell, copper half cell? Its answer is, or its equation, and as well as its answer is, its equation is Cu2 positive ion plus 2 mole of electron, double arrow, reversible arrow, Cu, that is equal to plus 0.34 volts if I'm not wrong. Right? What is the answer of E naught of this half cell, and what is the equation of this half cell? According to the data booklet, according to the reduction potential in the data booklet, the equation and the answer is over here. Zinc 2 positive ion plus 2 electron, reversible arrow, reversible reaction, double arrows, and it's going to make zinc solid. So here are these two basic reactions, overall half cell reaction, and here is its answer, minus 0.76 if I'm not wrong. And this is the E naught. Naught means standard. E for electrode potential, or that is also said to be electromotive force, and so on. Now in front of you there are two beakers. One is on the right hand side, let's suppose, and other one is on the left hand side. One is the right hand side. And here is a salt bridge. So after connecting these two half cell, what will happen? In my opinion, first of all, the first basic proposition, or the first basic job is to diagnose the flow of electron. To diagnose the flow of electron. So I am going to diagnose flow of electrons in external circuit, in this circuit. Now let me know which one equation or which one beaker is having positive answer, or more positive answer, or less negative answer, or higher value. Which one beaker is having the higher electrode potential? Let me know.
Copper.
Copper, exactly. What does it mean? This equation indicates the power of the reactant. This is the power of the reactant. I mean the power of copper 2 positive ion to gain the electron is plus 0.34 volts. And in this beaker, as you know, there is also presence of zinc 2 positive ion. The power of reactant, zinc 2 positive ion reactant, to gain electron is negative. Power of zinc 2 positive ion to gain electron is negative. What does it mean? It means that this zinc positive ion cannot accept electron by its own, by itself. You will have to apply the force of 0.76 volt. After that, it may accept, or it will accept the positive ion. I mean, this beaker, the tendency, the power of this beaker to accept the electron is negative. In this beaker will accept electron happily. Its power to gain the electron is positive, so it will snatch the electron. Its snatching power is higher, its snatching power is negative, less than 0. So one more thing, if I am going to reverse this equation, I am going to write like that: zinc goes to zinc 2 positive plus 2 mole of electron. Then the same answer, according to Kizzer rule, the same answer will be reversed. So it will be 0.76. So what does it mean? What does it mean if I am going to reverse this equation and this reaction can be reversed? Why this reaction can be reversed? Because it is a reversible reaction. This reaction can be proceeds in two directions, forward as well as backward. So yes, it can be reversed. It means that its reversal is positive. Its normal reaction is positive. This reaction, what is happening in this equation, please let me know. In this written equation that is in front of you, this one, what is happening? Oxidation or reduction?
Reduction.
Reduction, exactly. So this beaker is capable to perform reduction. This beaker is capable to do, what is this? Reduction or oxidation? I mean, this one. Oxidation. So this beaker can perform oxidation. I mean, it can lose electron. So through any mean, by any source, through any trick, through any tips and trick, I'm quite capable to mark the direction of electron. This is the movement of electron from the wire through the external circuit, through the voltmeter. And so this beaker will lose electron. This beaker will gain electron. And in fact, this copper rod will not gain electron. This copper rod will not gain electron. I'm going to zoom it out. This copper rod, basically, it is sending electron to the solution. This copper rod is not gaining electron by its own. Itself, it's not gaining. It is giving the passage to the electron through it. That is what I want to see. So here are the electrons. And what will happen now? The next thing is over here. In this solution, in this beaker, copper 2 positive ions are sitting over here. Same is the case beside copper 2 positive ion. Because of water, H positive ions are sitting over here. So which one positive ion is more capable to receive the electron finally? Which one? Obviously, copper. So copper 2 positive ion is more powerful to receive the electron. Finally, this thing will happen over here. So this reaction will happen over here. Copper 2 positive ion in this reaction will gain the electron and change itself into copper. So in this beaker, copper 2 positive ion will go to this terminal and there will be the more layer of deposition of more layer will be deposited for copper. So with the passage of time, the mass of this cathode will increase. Mass of this cathode will, this electrode will increase. Yes, it is cathode because reduction always happen at cathode. Got it? So with the passage of time, the mass of this rod will increase. Copper ion from the solution is going to deposit on this, rod. So what will happen? There will be the deficiency of copper 2 positive ion. If I'm adding initially, or I have added copper sulfate over here. So initially there were equal number of copper 2 positive ion and SO4 2 negative ion. But with the passage of time, you can see that copper 2 positive ion is going to migrate from the solution and it is going to deposit itself into a solid state. So it means that the remaining solution is going to enrich with excess sulfate ion. Remaining solution is now having continuously increasing concentration of SO4 to negative ion. A time will come when the reaction will stop. Why is this so? These sulfate ion, because when they are going to they are going to get high concentration, they will repel these electron. If there is more crowd of sulfate ion will repel the electron. Those are coming through the copper rod. So it means that reaction will stop. This circuit will stop. So to balance the neutrality of the beaker, to maintain the overall positive and negative charges in a balanced way, we use this salt bridge. In this beaker, there is a deficiency of positive ion. So from this salt bridge, potassium ion will jump into this beaker. Once again, I'm going to repeat. In this beaker, copper is depositing itself on this rod. And finally, there is a deficiency of copper 2 positive ion, and comparatively, SO4 2 negative ions are going to increase. So as the negative charge is going to increase and solution is going to be electrically imbalanced, so to rectify its concentration of SO4 2 negative ion, this salt bridge will lose itself potassium ion, potassium ion, potassium ion. Salt bridge is usually made up of potassium nitrate or potassium chloride. So here is a paste of potassium nitrate, paste of potassium aqueous nitrate basically. So in this beaker, this salt bridge, this tube that is having the paste of potassium nitrate, it will lose potassium ion, and at the mouth of this tube there is a membrane, you can say a barrier, permeable membrane, and so potassium ion will seep through this barrier into this beaker just to keep this solution electrically neutral. Now I'll come toward the other one beaker over here. Let's see over here what is happening over here. In this case, what is happening? This reaction is happening. Zinc rod is going to dissolve itself. Zinc rod is going to dissolve itself, and as it is dissolving itself, so it is changing itself into zinc 2 positive ion, and it is losing electron to the external circuit. So it is losing electron to the external circuit. It is jumping into the water after the loss of 2 electron. So this solution is going to be enriched with zinc 2 positive ion. It is going to be enriched with zinc 2 positive ion. So again, there is basically a danger of imbalancing the charges in this beaker. So this salt bridge will lose nitrate ion into this beaker to keep electrically neutral, or to neutralize the excessive positive ion in this beaker. Right? So this is the basic function of the salt bridge. Salt bridge basically, indirectly or directly, it keeps the electrical neutrality in both beaker. In one beaker, it sends positive ion, especially potassium positive ion. In other beaker, it's going to liberate nitrate ion just to keep the both solution electrically neutral. Now what is happening over here? As I told you, this zinc rod is going to dissolve. So this reaction is happening over here, And in the next beaker, this copper, this reaction is going to happen over here. I am going to write once again these two equations over here. Cu2 positive ion plus 2 mole of electron goes to Cu. In this beaker, there is a zinc solid. Here is solid again and aqueous. Solid is going to change into Zn, 2 positive ion aqueous plus 2 mole of electron. So its answer is, as I told you, plus 0.34. And we have flipped this equation, and we have also flipped the answer of this equation. So its answer is also, flipped, and it has become positive value, positive integer. So these two reactions are happening in the beaker. If they are asking to find the E naught of the cell, then simply you will add these two answers. Simple. One equation will be flipped according to the data booklet. Its answer will also be flipped. Then finally, I'm going to simply add them. So the answer is, 0, 1, 1, 1, 1. Plus 1.10 volt is the overall cell. This is the voltage that is appearing over here. So by the combination of these two half cell, the basic answer, the basic voltage that has been produced is 1.1 volt. So this is the theme. Now the next thing is, which one is the positive terminal and which one is the negative terminal? As we have announced it, a cathode, because here reduction was happening. So I called it cathode. Yes, it is true. Whenever, wherever there is occurrence or there is a happening of reduction, that is called cathode. In all type of cells where there is the happening of reduction, it will be cathode. And if it is cathode, then what is the nature of this zinc rod? It is acting as anode. So zinc is anode, copper rod is acting cathode. Until this zinc is alive, it's going to behave as an anode. And this copper rod is going to behave as a cathode. So we have marked anode and cathode. Now the last thing is, I'm going to mark the polarities. So how to mark the polarities? Which one is the positive terminal and which one is the negative terminal? So there is another theme. Don't mark the polarity with respect to anode and cathode. This rod that is receiving electron, it can never be a negative. Any species that is welcoming the electron, that is allowing the electron to pass through it, will never be the negative. So it will be positive terminal. This is positive terminal because it's accepting, it's welcoming the electron. This is losing electron. It is repelling electron. So obviously here this terminal will be negative terminal. Although its name is anode, but this terminal will be negative terminal and this will be positive terminal. This is called anode. This is called cathode. And here is the movement of electron. And whenever they are asking to write the movement of electron, then you can write from left to right. So left to right, or from this zinc half cell to the copper half cell, and so on. Whenever they are asking to find the answer of overall E naught of the cell, mean whenever you are going to add whenever you are going to connect them, and what is the overall number of voltage or value of the voltage that is being formed, is this one. And yes, they can ask what is the overall reaction. So in case of overall reaction, I'm going to add these two equations. First of all, number of electrons should be equal, should be same. If I'm going to equalizing the electron, so if the electrons are not equal, if initially electrons are not equal and you are going to multiply by 2, 3, 4 and something else, then at that time there will be no change in the value. I am going to repeat it again. If for the sake of balancing electron, if any equation is multiplied by 2, 3, 4, 5, 6, 7, then its answer will not be changed because the ratio of overall all species will remain same, right? This value will change. Yes, it can be changed whenever you are going to increase or decrease the concentration, whenever you are going to change the temperature. So as you know, these both are reversible reaction. So here is the formation of, or here is the application of KCKP, especially KC. So you can change this answer if you are going to change the concentration of positive ion, or any other 2 positive ion, zinc 2 positive ion, or copper 2 positive ion. Or if you are changing the temperature, then all type of constant are changed. All type of equilibrium constant are temperature sensitive. So by changing the temperature, value of Kc, Kp, Kpc, Ksp, K stability will be changed. At the moment, how to make overall equation? So electron should be equal. So I'm going to cancel them out. What is the answer? The answer is over here. Copper 2 positive ion is going to react with zinc solid to give Cu solid and plus zinc 2 positive ion. And as I told you in my previous lectures, and you can write it a reversible reaction, and I have written an equation. Equation mean equality. Mean this equation must be a balanced equation. By default, it should be the balanced equation. So it's a balanced equation. So this is happening over here. Overall, this is happening in between these two cells. Zinc is losing its mass. It is changing itself into iron. Copper is going to gain its mass. Pinkish brown solid is going to be deposited over here. Gray solid is going to dissolve itself. Blue solution for the copper is going to be fade away. The color is going to change its speaker, and so on. Again, at this stage, I will repeat it again in next lectures. Again, at this stage, if I'm going to increase the more concentration of copper 2 positive ion, if I'm going to add more concentration, more than 1 mole per dm cube in this beaker, I'm going to add more copper sulfate, more copper sulfate, then what will happen? The overall E naught of the cell, that is initially 1.10 volt. Then what will happen? So if I'm going to add more coppers to positive ion, equilibrium position, or the position of equilibrium, will be shifted towards the right hand side to compensate the higher concentration of the copper. So equilibrium, as the equilibrium is shifting towards right hand side, simply it means answer will increase. If equilibrium is shifting towards right hand side, answer will increase. If you are doing anything and equilibrium is shifting towards the left hand side, if the equilibrium is shifting towards reverse direction, toward the side of the reactant, this answer will then decrease. In this case, if I am going to increase the concentration of copper 2 positive ion, the new value will be more than 1.10, but it will not be E naught. We cannot write this symbol over here because under standard condition, this is the answer. Now the new answer will not be under standard condition. It's called simple E cell. It was E naught of the cell. It is simple E cell, and this is how I wanted to explain today.